All right, so we've spent the last several lessons talking about how to solve exponential equations. And really, there are like two very separate strategies that we used to do that. In the first section, 24.1, we learned to do that by making the bases match. And then in 24.2, we looked at how to solve exponentials using logarithms when we can't make the bases match. So today we're now going to look at solving logarithmic equations. And in the last section, we talked about how logarithms and exponentials are inverses of each other. And so when we are trying to undo a logarithm, what we are doing is trying to make it into an exponential. So we're going to rely on properties that we've actually already learned. We've learned these properties in the simplifying of logarithms, and we're going to use them in order to now solve. So the two main ones that we're going to use to actually solve and get our variable alone are the Swoop method and the property that if two logs with equal bases are equal to each other, then that means that their inputs have to be equal to each other. So the reason that this statement right here is true is because these are both log base b. And if these two same based logs are equal to each other, then that means that those inputs had to be equal. So x would have to be equal to y. Now this property, remember, only works if it's a single logarithm with the same base. So underline that, that's really important. Single logs with the same base is what that property is for. So once we've done one of those things, just like we talked about in the last lesson, then we're just going to have some sort of normal equation that we already know how to solve. It might be linear, it might be quadratic, but we'll use all of those previous skills from Algebra 1 and from earlier units in order to do that. So once you have an answer, we do need to check to make sure it isn't an extraneous solution. And an extraneous solution means a solution that doesn't work. You can press the whole problem into your calculator to check it. That's fine, but you don't have to. Really, the only time we get extraneous solutions is if we're trying to take a log of a negative number. So if our input is negative. So if the input is negative, then that means that it's extraneous. All right, so we're going to look at a couple examples here, and you can see that they, look different from each other. Here I've got just one log. Here I've got two with addition. Here I've got two, but they're on opposite sides. Here I've got subtraction. Here I've got an ln. So we've got all kinds of different looks here. When I have just a single logarithm, that is where I'm going to go back to how I converted from logarithms to exponential form. And it's the exact same thing that we've learned two separate times now. So this is now the third time we're learning about how we can swoop around and do this. So 4 to the second power equals x plus 3. So base, answer, exponent. Okay, so now it's just a regular equation that we need to solve. So 4 squared is 16. So I've got 16 equals x plus 3. Subtract 3 on both sides, and that gives me 13 equals x. Every single time, we want to check it to make sure it's not going to give us the log of a negative number. So in this case, if I plug in 13, 13 plus 3 is 16. That's not a negative number, so I'm not taking the log of a negative, so I know that it works. If it's easier for you to just check the whole thing in your calculator, you can certainly do that too. So if you want to press in And in the earlier lessons, sorry, of course, now my software is trying to validate. So maybe I'll get rid of this for now and just show you that on the next one. Okay, now our swoop method does not work if I have more than one logarithm. I can't swoop from two different places. So what we have to rely on here are our properties for condensing logarithms. Remember that if logarithms have the same base, which these do, they're both base 2, that when I have addition, that means that I can use that product property and condense this to one logarithm using multiplication. So keep the base the same, but now what I'm going to do is I'm going to multiply these inputs. So 2x times x minus 3. So it goes right with the exact same stuff that we were already learning. Now it's a single logarithm, so now it's in the correct form, and I can swoop it just like I did on part A. So 2 to the third power equals this whole thing, which I'm going to go ahead and write it out in distributed form, so 2x squared minus 6x. This guy is 8 over here, and I notice that this equation is quadratic. So quadratic equations, I need to get them equal to 0 so that I can solve. So 2x squared minus 6x minus 8 equals 0. And now I'm going to factor. So pull out the 2 because that's a common factor. Now I have x squared minus 3x minus 4. So I'm looking for what multiplies to negative 4 and adds to negative 3, which if you immediately said negative 4 and 1, because those do multiply to negative 4 and add to negative 3. So that factors then into x minus 4 times x plus 1. And if I'm solving for x, that means I want to set each of these factors equal to 0. So x minus 4 equals 0 and x plus 1 equals 0. So this gives me x equals 4 and this gives me x equals negative 1. So when I plug these back in to check them, 2 times 4 is 8. So that's positive, that's fine. 4 minus 3 is 1, so that's fine too. So x equals 4 is going to work. X equals negative 1. 2 times negative 1 is negative 2. So that gives me a negative input. That means that this is extraneous, and I need to cross it out because it doesn't work. Now, what I was saying earlier when my calculator wouldn't load, if you want to press the whole thing in to your calculator to check it, you can. But you don't need to. What I just did by hand is plenty, but if you try to press in log base 2 of 8, or sorry, not of 8, 8 worked, of negative 2, so remember that they taught you in a previous one, if you have the shortcut, math choice A, so log base, and this was base 2, so log base 2 of negative 2. If I try to press that in or press the entire problem in even, when I press enter, it's going to tell me error, non-real answer. So that's also how you know it's extraneous. So if you don't have the log base on your calculator and you don't want to take the time to use the change of base formula, then just do what I did here. It's quicker anyway, I think. Okay. Now we're going to look at C. C is a different type because I do have two logarithms, but they're on separate sides of the equal. And when that happens, that looks like this up here. So this is Swoop method, is when I can get it to a single log. This property is when I have one log on each side, which is exactly what I have in C. When I have one log on each side, as long as the bases match, I just get to drop those logs and bases away because they match. So I'm just going to do x plus 3 equals 8x plus 17. So now it's a really simple algebra 1 question to solve. So subtract x on both sides, then subtract 17 on both sides. So negative 14 equals 7x. Divide by 7, and x equals negative 2. Now, in this case, when I plug in negative 2, I get negative 2 plus 3, which is 1. That's a positive number, so that's fine. Over here, 8 times negative 2 is negative 16 plus 17, also 1, so also a positive number. So this is a valid solution. So you can see just because the answer itself is negative doesn't mean that the input's going to be negative. Okay, so now I'm going to look at D. So D, I have a single logarithm. Notice that it's an ln, but this single logarithm is not alone. Remember that in using the Swoop method, the single log has to be alone. So here, before I can do any of that swooping, I have to subtract the 7, which gives me this guy. Then I still have to divide this 2. This is the step that a lot of people forget. You have to divide that away. You can't have a number in front of the logarithm if you're wanting to use the Swoop method. So now the logarithm is by itself. All I have is the logarithm, a base, which we don't write it here because when it's ln, we understand that the base is always e, and my input. So now I can use the Swoop method. So you don't have to write it in. I'm just writing it in for illustrative purposes. This gives me e to the 7/2 power equals negative x. Now, to get x alone, I would divide everything by negative 1, which is just going to give me negative e to the 7/2. Now, sometimes you are asked for exact answers, and sometimes you are asked for approximate answers. So you have to really pay attention to the directions in your homework and on assessments. This is an exact answer. If it asks you for an exact answer, this is it. This is all that you do. If it says round your answer to 2 decimal places or 3 decimal places, that's when we would go back over to the calculator and I would actually type that in. So negative sign, and then right above the ln is the e to the x button. And my e to the x, it's 7/2, so I'm going to put it in parentheses and press enter. And that gives me negative 33, let's say we're rounding to 2 decimal places, 0.12. And again, you would follow the directions. If directions asked to approximate or round, then we would write approximately negative 33.12. Now, we would of course always check this. I kind of already put the boxes around them, so I guess that gives it away that this does work, but I do need to check for extraneous. The opposite of a negative is a positive, so this does pass our test. It is not an extraneous solution. All right, final example here. Again, I have 2 logarithms and they're not on opposite sides, plus I've got extra stuff over here. So this is going to be similar to B. I need to condense first using properties because they have the same base, and then I can work my other steps. So subtraction condenses with division, just like this. So remember, whatever came first goes in the top, whatever came second goes in the bottom. Now it's a single log, and that single log is all by itself. There's nothing multiplied, there's nothing added or subtracted on the end. It's just the log, the base, and the input. So that means I can go ahead and use my swoop. 4 to the second power equals x plus 6 over x. And so 4 squared, of course, is 16. When I have rational equations like this, I need to multiply both sides by x so that I can get that off of the denominator. So that gives me 16x equals x plus 6. Then subtract x on both sides. So 15x equals 6. Divide by 15, and x equals 6 over 15, which those are both divisible by 2. So we're going to, no, they're both divisible by 3. So I can divide both the top and bottom by 3, and that gives me 2 over 5. Now, I want to, as we wrap up, talk about two things. Here, the 2/5 does work. 2/5 is positive. Here, 2/5 plus 6 is also positive. But I want to talk about two things. Number one, the difference between when I would round and here where I would never use a decimal. Here I would never use a decimal because I can write my answer as a fraction. The only reason we may be asked to round here is because it has an exponential, because it has an e with it. Most of the time, they're probably going to ask for the exact answer, and what you have is here. But remember, we never, ever, ever use decimals unless we've been specifically told to in the directions, or there's a decimal in the original problem, or it's a real-life situation. These are not real-life situations. There are no decimals in the original problem, so unless it tells you to, you should give the exact answer. The other thing that I want to cover, I gave an example of an extraneous solution up here, but I want to cover what happens if your only solution is extraneous. So if I had plugged this 13 in and it gave me a negative input, I wouldn't just cross it out and write extraneous. I would then need to write no real solution because I have to have an answer. And extraneous itself is not the answer. No real solution would be the answer. All right, so you've got tons and tons of examples here that we've gone through. Should be able to find things to match up with what you're asked to do in the homework. Make sure that you check in with your teachers to get your questions answered.